Let's take a look at Chapter 29, the section on EIFS, which is Exterior Insulation and Finish Systems. The Exterior Insulation and Finish System, abbreviated EIFS, and generally pronounced as EIFS, consists of a layer of a rigid polystyrene foam insulation, a fiberglass reinforcing mesh, a polymer-based base coat, and a polymer-based finish coat. The reinforcing mesh is embedded in the base coat. Because, in its finished appearance, an EIFS-clad facade looks like stucco, it is also referred to as synthetic stucco to distinguish it from Portland cement stucco. The description of the EIFS just given is that of a basic system. More sophisticated and hence more complex systems are available. The important fact to recognize is that an EIFS assembly is a system because it comprises several chemically complex materials. Compatibility between system parts and also among the substrate, trims, and joint accessories, flashings, sealants, and so on must be ensured. Therefore, all materials for the assembly must be obtained from one manufacturer and applied per the manufacturer's instructions. The manufacturer's warranty for the system is generally contingent on the use of its approved material distributor, certified applicator, and recommended construction details. The EIFS Industry Members Association, EIMA, a trade organization representing EIFS manufacturers, classifies an EIFS into two categories: polymer-based, PB, and polymer-modified, PM. Polymer-based, PB, is also called soft coat EIFS, and polymer-modified is also called hard coat EIFS. In the PB system, the insulation consists of expanded polystyrene, or EPS, molded and beaded boards which are adhered to a substrate. The total thickness of the PB EIFS lamina, mesh, base coat, and the finish coat is approximately 1/8 of an inch. The PM system uses extruded polystyrene, or XPS, or polyisocyanurate, ISO boards, which are anchored to the substrate using steel screws and plastic caps. The base coat on a PM system consists of polymer-modified Portland cement and is at least 1/4 inch thick. The PB system is far more commonly used and is the one described here in further detail. Although most manufacturer systems are similar, there are differences between them. Therefore, the manufacturer's literature should be consulted for more authoritative information. If you look closely at these details, you'll notice subtle differences. For example, in the PB EIFS system, the EPS beadboard is glued on with ribbons, whereas on the PM system, the XPS or ISO board is mechanically fastened. So that's one of the big differences here. Then notice both of them have fiberglass mesh that's embedded into a base coat, but remember the finish coat on the PM system is 1/4 inch thick versus 1/8 of an inch on the PB system. Let's take a look at the application of polymer-based EIFS. EIFS is a versatile cladding and is used for all types of projects: low-rise, mid-rise, and high-rise buildings, in commercial as well as residential projects. It can be used over wood frame, cold-form steel stud frame, concrete, and masonry walls. The use of rigid foam insulation in EIFS has several advantages. First, it is energy efficient because placing insulation on the exterior of a wall assembly results in a higher effective R value than placing it within or toward the interior of the assembly. Second, the foam insulation allows a great deal of detail work to be easily incorporated on the facade. The foam can be molded to shape, it can be cut out to provide grooves for surface relief, and its thickness can be varied to give accent bands. The surface detail remains virtually unchanged after the application of the base and finish coats because of their relatively small total thickness. Third, a large variety of colors are available in EIFS finish coat. Most EIFS clad facades are richly detailed and variously colored. Few other cladding materials lend themselves to such ornateness and bright, relatively facade-resistant colors as EIFS. Therefore, a mock-up panel of EIFS cladding is all the more important in most projects. Fourth, EIFS does not require control joints, such as those used with stucco, adding to its versatility. Fifth, EIFS is one of the least expensive exterior wall claddings available today, less than any other system discussed in this and the previous chapter. The first step in the application of PB EIFS is to adhere the insulation over the liquid applied air weather retarder placed over the substrate. The adhesive is applied to the back of the insulation in ribbons using a notched trowel. After the adhesive is applied, the board is pressed against the substrate to which it clings instantaneously because of its light weight. The boards are arranged in a running bond pattern to avoid continuous joints. Once the insulation boards have been installed, they are sanded smooth, a process known as rasping. Rasping removes surface irregularities resulting from an uneven substrate or uneven insulation boards. Generally, more than one sander grade is needed to obtain the required surface. If aesthetic grooves are needed, they are cut into the insulation boards at this stage. The minimum thickness of insulation behind the groove must be at least 3/4 of an inch. In example A, the cutting of reveals or aesthetic grooves in the insulation after it has been adhered to the substrate with the help of a groove-making tool and a level. B, a close-up of the groove-making tool that makes a V-shaped groove. The tool can be adapted to make grooves with different profiles. Before the base coat is applied, the terminal edges of insulation boards at the foundation and around openings are wrapped with a reinforcing mesh, a process known as back wrapping. The reinforcing mesh is embedded in the base coat. Back wrapping strengthens the edges and functions like casing bead in conventional stucco. After the edges are wrapped, the base coat is applied. Immediately afterwards, the mesh is unrolled over the base coat, and using a trowel and some additional base coat material, the mesh is fully embedded in the base coat. The finish coat is either sprayed or troweled on over the base coat. Because both the base coat and the finish coat are polymer based, the EIFS lamina is a relatively flexible membrane. Therefore, an EIFS clad wall does not require any control joints. Expansion joints are, however, required where large movements in the structure or substrate are expected. These locations are A, at the spandrel beam level, B, where an EIFS clad wall abuts a wall of a different material, C, at major change in wall elevation, and D, at a building expansion joint. This figure shows a typical expansion joint detail in an EIFS clad wall. Let's take a quick look at impact resistant and drainable EIFS. Impact resistant EIFS consists of 2 layers of base coat. The first layer is embedded in a thicker reinforcing mesh, and the second layer has the same mesh as a standard EIFS. Although the impact resistant EIFS has higher compressive strength than the standard EIFS, it is not equivalent to the compressive strength of most other cladding systems. Therefore, in many projects, the first few floors of the building are clad with a high compressive strength cladding, such as masonry veneer, concrete, or stucco, and the higher floors are clad with EIFS. There are two types of drainable EIFS wall systems available. The system with insulation adhered to the substrate has vertical drainage grooves at the back of the insulation. The other system, in which the insulation is mechanically anchored to the substrate, has a thin drainage mat and an air weather retarder behind the insulation. The drainage mat is typically made of interwoven plastic strands. As an alternative to the mat and building paper, one manufacturer uses a layer of synthetic material with drainage lines. Both systems require a perforated plastic track at the bottom to allow water to weep at the base. In a multi-story building, the tracks are provided at each floor level. In this image, we're looking at a drainable EIFS system in which the insulation is adhered to the substrate and the drainage is provided by vertical grooves in the insulation. You can see the ribbons, the adhesive ribbons, and here are the drainage grooves that are part of the insulation system. This drainable EIFS system is mechanically fastened to the wall framing members, and the drainage is provided by a drainage mat. So if you take a close look at this, you can see the drainage mat, and then we have tape over a sheathing joint right here, and then we have an air weather retarder on the back side of the drainage mat. So here's our fasteners, here's our insulation layer, our mesh, the base coat, and the finish coat.